Hi, everybody. We are going to be looking together at a three-dimensional model of the different types of plate boundaries we've been studying so far, the convergent and the divergent. So we're going to start with a convergent boundary. And what you should see here is you should see two chairs. You've got two plates, one here represented by this towel. This represents a continent. That's why it's really, really thick. And this plate represents thin oceanic crust under the bottom of the ocean. And remember that in a convergent plate, what we have is we have two plates that are moving toward each other. So if we were to use my hands as a model, these are two plates that are coming together. They're coming together like this. And so what we're looking at here is we should be looking at the two plates going together. And what happens as these two plates go together, as this plate moves towards this plate over here, and this plate moves towards this plate over here, you'll notice that this plate, the thin oceanic one, is forced underneath down below. And you can see my hand down here. My hand is now in the mantle, at least of this model. And there's that plate, which was a nice firm plate sitting across the top of the mantle, but now it's inside the mantle, it's getting all floppy, and it is becoming magma again. It's no longer solid rock, but now it's magma, and it's pushing underneath down there, and it can then become part of the convection cycles again. So again, these two plates are moving closer together. This plate is moving underneath the other plate, right? And then this plate is moving on top of it. And so the continent stays on top of the oceanic plate. This process has a name. It's called subduction. We're going to talk more about that at another point. But for now, you can just think about it as one plate going under another at a convergent boundary, a coming together boundary.